Okay, so good morning once again. Welcome to the third phase of our short-term training program. This is an AICTE sponsored program. So we have already completed two phases successfully. This is the third phase. So welcome to all the participants who had joined with us previously in the two phases as well as in the third phase, as well as I also welcome the new participants in this program on recent trends in Internet of Things and embedded system based monitoring and control of distributed generation. This is a very burning topic as well as it covers a long range of disciplines. It has embedded system, it covers Internet of Things as well as the power system. So we have tried to gather experts from different fields of academia as well as industry, experts from CSE department, EC department, as well as from the Department of Electrical Engineering. So all the experts are there and from different parts of India, NIT, Calicut, Warangal, Meghalaya, IST Shibpur, Jadavpur University, and we have also kept four hands-on sessions this time. We had kept similar hands-on sessions in the first phase also. In the second phase, we kept two, and in the third phase, we are keeping four. So, and they would be quite interesting, and I would request all the participants to definitely be present not only in the lecture sessions but as well as in the hands-on sessions as well, which you can do quite conveniently at your home. Welcome once again, and I would like to mention 2 or 3 points that every day after the entire session is completed as part of the program schedule, feedback and an attendance link will be circulated, and on the last day an MCQ based question answer session will be given to the participants. Actually it will be in Google Sheet and it will be circulated to the participants, and I would request you all to submit the answers within the stipulated time. It will be an MCQ based and the questions will be quite simple for you. And because it is an AICTE based program, so as per the guidelines, actually they have mentioned that around 60% marks is necessary to receive the certificates. So I request you all to spare some amount of your time in answering the questions. Okay, so with these words, I would now request our Dean R&D, Professor S.C. Konar, to say a few words to the participants and to all over here who are present. Sir, please.
Thank you, Navamita. Good morning to all. Respected Principal Madam, Register Madam, dignitaries, my colleagues, and participants. Short-term training program intends to conduct a faculty training through finding assistance from AICTE. AICTE approved technical institutions or university departments with at least 7 years of existence are eligible to apply for this program. All teachers, supporting, technical, and administrative staff in areas of technical education in AICTE approved institutions are eligible to participate. Modern technologies such as the Internet of Things offer a wide number of applications in the areas in the energy sector, that is in energy supply, transmission, and distribution and demand. IoT can be empowered for improving energy efficiency, increasing the share of renewable energy, and reducing environmental impacts of the energy use. Industrial regulations can be divided into 4 phases. In the first regulation, new sources of energy were discovered to run the machines. The mass extraction of coal and invention of a steam power plant were of development stages. The second revolution, known as mass production and electricity generation, was a period of rapid development of industry. The third revolution introduced computer and first generation of communication technologies. The fourth industrial revolution, a wide variety of modern technologies such as communication systems, 5G, intelligent robots, and the Internet of Things. IoT interacts a number of devices, people, data, and processes by allowing them to communicate with each other simultaneously. With these few words, I wish you all the best and continue with the final stage of the program. Thank you to all.
Thank you, sir. Now, in this inaugural session, I have invited all the resource persons, but actually, perhaps many of them couldn't join because of other engagements. But yes, one of our resource person, Mr. Joydeep Nath, has joined with us. He is from Micropro. He will also be taking a hands-on session in this program. So, I request Mr. Joydeep Nath to say a few words.
Good morning, everybody. I'm very happy that you have welcomed me in this program. And first of all, I'd like to congratulate all the participants, Dean R&D NIT, HOD Madam Navamita Banerjee, and all. This program is very interesting, no doubt, and very useful as well. What we have known regarding the background of the IoT, everybody know the term IoT is very, very popular to in our nowadays, and it has enormous application. There are hardly any field we not use IoT. I don't know exactly where it never use IoT. So it's a such a growing field nowadays, and IoT, that everywhere I can use IoT. IoT. So IoT is a very important term, and everybody should know the application and implementation of IoT, and very essential from practical point of view and implementation point of view. So I will request all of you, all the participants, to very seriously attend the class, the lecture. My lecture session will come on 9th September around 2 p.m. So I will show you some practical applications and some brief description of the experiments, as well as what is IoT more in detail. And beside this, which I want to say that we can develop very interesting gadgets, devices by means of IoT technology. And IoT we can also connect it with the automation system as well, and which is another interesting field, automation system, that all the industrial data or all the process data we can transmit over internet anywhere, any position, any location in the over the globe by means of this IoT technology. Because the PLC, SCADA, all are basically the main fragment wing of automation. So suppose we collect a lot of temperature data, a lot of pressure data, a lot of analog data rather, and due to the data logging system of the SCADA part, we can accumulate the data, and finally we can transmit it over the internet by means of IoT technology to anywhere in the world, anywhere, any location. Suppose there is an industry company which has a plant in India, and then their head office in USA, and several other parts of the world, obviously. So the plant operations, whatever plant operations is going on, and the data and the everyday update of the plant situation, we can update, we can send over Internet of Things by means of the data we can send to anywhere in the world through Internet of Thing, thing, and the proper useful networking system. So it's another example of IoT in the industrial field. In our everyday life, say home automation is a very common example. Everybody we know. Everything we can automate in our home, in our residence. Nowadays, that there are multi-storied building in Calcutta, then several sophisticated building also implementing IoT technology for make their life more easier, more simple, rather than by using only, if you just switch on your mobile, you need just a sophisticated mobile or a smartphone, and from the smartphone, from the mobile, everything in your house, everything which is located some distance away from your house residence, you can control. Suppose you forget to switch off your geyser, and now right now you are out of your house completely, and you have already covered a 1 kilometer distance or 2 kilometer distance from your house, and suddenly you remember that your geyser is on, and you have a little bit doubt about whether it is on or off, then immediately you can monitor the situation, and you can, if it is on, you can make it off. If any light in the light, fan, or whatever is TV, refrigerator is on in your room or in your residence, you can or on it, you can off it, even you can on it from any distance location. So these are the most powerful and important application nowadays by means of IoT. So I welcome once again to all of you. Please come and participate on 9th September. I will show some examples. I will show some practical examples, which will be definitely important and essential to know in terms of your subject. So thank you, everybody. Thank you, all participants. So, okay, thank you.
Thank you, Mr. Jyoti, for giving a brief explanation of IoT as well as its application so nicely. Uh, our first speaker is Professor T. Kishore, so he'll be joining with us shortly. So till then, I would request all the participants joining with us gradually. They have not joined, all of them have not joined in. Perhaps they are joining with us gradually. So let us please wait for a moment because as the first lecture session is going to start from 11 a.m. and our speaker will join with us. Hello. Our head of the Department of Information Technology, Professor Mita, has joined with us in the inaugural session. Sir, would you like to say a few words in this program to all the participants? Hello. Professor Mehta, would you like to address to the participants? I think he has not listened.
Hello. Hello.
একটু রাখ। Hello, good morning, sir.
Good morning. I'm just switching on my video actually. Yes. I'm logging out
Okay,
and
sir.
you're logging in. Just one. Okay. Please. Yes.
Okay.
Hello. Is it coming? Hello.
Yes, sir, it is coming.
Yeah. Good morning. Good morning, madam.
Well, so I would request you to say a few words. Okay, I would request to say a few words. Today is the inaugural session. Today is the first day of our program. Would you like to say a few words, sir?
Okay. Yeah. Good morning, everybody. Am I audible? Hello.
Yes, sir, you are audible. Yes, sir, you are audible.
Good morning, everybody. This is right. It's STTP. Fine. What's the name? Okay. So it's great. Just that IT department, electrical department is organizing this STTP on recent trends in Internet of Things and embedded systems based monitoring and control of distributed generation. So this Internet of Things and both embedded system both plays a vital role in all aspects of our life in recent times. and in particular, and in the distribution generation, they are the everything now is monitored and controlled remotely. So for that, we need some monitoring system, and that to become smart, that so IoT is needed with some embedded system. So that's a good topic and relevant topic, and the department is organizing this short-term training program. So I hope all participant, not student, mostly faculty, but participant will learn a lot from this. So I wish you all success, madam. Thank you.
Thank you, sir, for encouraging words. We are waiting for the first speaker of this session. He will join sharply at 11 a.m.
Okay, fine. So this is the first phase, no? Isn't it? Or phase 3 means what?
This is the third phase. As
Third.
per the guidelines, this time the STTP has to be conducted in 3 phases. So this
Okay.
is the third and the final phase.
Okay. So all phases in 5 days duration. All
6 days duration.
6 days duration in all 3 phases. Okay. So that will be the concluding phase. So this one.
Yes, this is called concluding phase. It has been I mean it's very challenging to conduct 3 phases.
Yes. That is okay. Actually, previously we conducted one 15 days FDP. So that time it was in physical form. So that too also very tough job to continue this type of STTP program for a long time. Okay.
Yes, sir. Yes.
Okay. Thank you,
Anyway,
madam.
okay, thank you. Sir.
Good morning, madam. Hello.
Hello. Hello. Good morning, sir.
Is it audible?
Welcome. Yes, sir, you are audible. Welcome to our program. We are all waiting for you,
Yeah.
actually. Okay, sir. I would
No,
request.
actually, my timing you said
It's okay.
11
Actually,
o'clock you said. That's why.
yes, sir. It's okay. Okay, sir. Actually, the inaugural program ended shortly. That is why. So, just we need
Okay.
to keep the participants locked down. So, we will have a brief introduction of you, for which I will request our Rupa madam. You please
Yes,
introduce
madam.
Professor Kishore to the participants.
Okay, okay.
Thank you, madam.
Good morning and welcome to everyone present here. Am I audible?
Yeah.
Okay. Now we are entering towards our first session of today. Today we have Professor Dr. T. Kishore Kumar as our honorable guest for the first session, and he is already with us. It will be my privilege to introduce our honorable sir. Professor Dr. T. Kishore Kumar, Department of EC and Head Computer Center, NIT Warangal, received BTech in Electronics and Communication Engineering and MTech in Digital Systems and Computer Electronics from Sri Venkateshwara University and Jawaharlal Nehru Technological University in the year 1992 and 96 respectively. He obtained PhD degree in the area of signal processing in the year 2004. With his unflinching commitment and ardent passion towards teaching, Dr. T. Kishore Kumar headed the Department of Electronics and Communication Engineering, NIT Warangal, during March 2015 to November 2017. Currently, he is a professor of EC and heading the Institute Computer Center from April 2018. Recently, he has been selected as a visiting professor for Asian Institute of Technology, Bangkok, during the previous semester, August to December 2019, under second meet of Indian faculty by MHRD, Government of India. He was awarded Research Excellence Award 2017 by Institute for Exploring Advance in Engineering for his research work. Sir published in Neurocomputing March 2017 and Best Engineering Researcher Award 2017 by NIT Warangal and NIT Warangal Alumni Association in recognition of his outstanding research, consultancy and training in the field of electronics and communication engineering. Dr. T. Kishore Kumar has contributed substantially to the qualitative research endeavors in the department. His current areas of research include signal processing and speech processing. He has completed 2 DRDO projects worth 18 lakhs and 1 MHRD AICTE pedagogy project worth 7 lakhs. To add another feather in his cap, he has the credit of receiving 2 major research projects sponsored by ACRB worth 41.92 lakhs. Besides this, he also has 2 ACRB projects worth 47 lakhs and 25 lakhs as co-investigator. Over the past decade and a half, he has taught several courses at UG and PG levels at NIT Warangal. Under his amiable guidance, 9 scholars have been awarded PhDs. At present, 5 PhDs are guided by him. He has also guided over 22 MTech and 30 BTech students. He has published 28 international journals and 20 international conferences during the last 5 years. Dr. T. Kishore Kumar has traveled across many countries like Czech Republic, France, Israel, Singapore, Dubai, Estonia, that contributed to his academic excellence during his academic and administrative career spanning over 2 decades. He has organized several faculty development programs in the domain of first signal processing, speech processing, and real-time embedded system at NIT Warangal and outside. He has coordinated MHRD, initiated GAN course in 2016. He has delivered several guest lectures at DRDO, ECIL, JNTUH, and other institutes of repute in Andhra Pradesh, Telangana, and Maharashtra. Dr. Kishore Kumar is a member of IEEE, ISTE, IETE, and senior member of IACSIT. He is a member of Board of Studies in NIT Warangal, Kakatiya University, JNTU Hyderabad, and SV University. He is also a PhD examiner for NITs and several other universities across the country. Sir, so welcome in our STTP phase 3. The session is all yours, sir.
Madam, and said, please hold on for a moment. Our principal madam has joined just now.
Okay.
Welcome, madam. I would request our principal madam to welcome and say a few words to the participants and to the faculty members and to all of us. Madam, please.
Thank you, Dr. Navanita. You are conducting the STTP AICTE Consort STTP program since long days, and this is your third phase. I wish all the best of your departmental program, and also I, as a principal of this institute, I convey my heartiest welcome to all the speakers. They have given their valuable times, and already they have given, and they will contribute their time again. I think Mr. Dr. Kishore Kumar was also the speaker. Last time also he was the speaker. So thank you, Dr. Kishore Kumar, for giving your time. And also now, till now, you are supporting us, giving your time, sharing your valuable inputs to our faculty and staff members. And I believe all faculty staff members in this platform, they will be enlightened with the knowledge getting from the resource persons during this 5 days program again. So I wish all the best. Thank you. And also I am very much sorry for my late joining. Okay. Thank you. Carry on, Dr. Banerjee.
Thank you, madam, for your encouraging words and your support. Now I would request Professor Kishore to start your lecture, sir, please.
Thank you, madam. Thank you very much, principal, coordinator, madam, and other participants of the program. And good morning to you all. Is it audible, my presentation?
No, sir. Follow.
Is it audible, madam? Hello?
Now it's visible.
Yeah, sir,
now your slides are
yeah. Sir, it's visible.
Visible. So my topic today is I thought I want to give introduction about embedded systems, and starting with a system, and then how do you define embedded system, what are the classifications of embedded system, characteristics of embedded system, and then I'll give some examples of embedded system and how to design an embedded system, what are the abstract rules that are needed to design an embedded system, and then finally applications of embedded system that I want to explain. Okay, so coming to the beginning, before going to see the embedded system, first of all, we should discuss about what is a system. So a system, it's a way of working, organizing or performing one or more tasks according to the fixed set of rules, program or a plan. So generally what we can call it as a system. So examples, common domestic applications are the examples for a system is a watch. So it may be any type of a watch, a time display system, where it will follow some rules so that it will display the time that we will consider as a system. So because it performs some particular task like minutes, seconds, hours, like that. Similarly, a washing machine is also an example for a system. So time display system and automatic cloth washing machine washing system, they are the two systems are the examples of a system. Coming to what are embedded systems. So now, just now we have seen the system. Now the embedded system means with respect to the system, I can say that it's an engineering product. So any engineering product, if you want to use it, we need to have some particular application. And in order to achieve that application, what we will do is we need to provide some particular control. So in order to achieve this particular control, what we will do is we will try to incorporate a computer within the product to undertake the control. So then if you incorporate or if you embed a computer within a particular system to achieve the control, then it is called an embedded system. So basically the main purpose of embedded system, it's not a computational domain, but where we need to achieve a control which is controlled by a computer embedded within it. So as we have seen that there are different applications in home, office, factory, car, or hospital. We can see multiple applications in all these particular areas. So in all these particular, you are seeing that a bullet train, a car, bench car, or some particular automated house, or different types of mobile, the electronic gadgets, where in all these particular applications, there is a computer embedded within that particular system. So to achieve the control. So what is that particular computer? We are embedding a computer within a system to achieve that control, to achieve the control. So basically a computer, everybody have the idea that basically a computer is a system which is having these particular components. So why I'm telling these things? Because an embedded system also which consisting of all these particular components. So one is the microprocessor. So then the second one is a large memory of the following two kinds. So one is the primary memory and another one is the secondary memory. As usual, in the case of the primary memory, we have a random access memory, the read-only memory, and there are different types of memories. We are not touching that, but a large memory which consists, and there are input-output units such as touch screen, modem, then different type of things, and then there are input units, output, and there is a networking unit such as Ethernet card, front-end processor, and an operating system that has general purpose user and application software in the secondary memory. So like this, we have all these particular components in a particular computer. So what I said is in order to achieve the control, we need to embed a computer which is having all these particular components which we are inserting in a particular system. So based on that, so an embedded system, we have different types of definitions that we observe. An embedded system is a system that has software embedded into a computer hardware, so which makes the system dedicated for an application or a specific part of an application or product or part of larger system. And similarly, an embedded system is one that has a dedicated purpose software embedded in a computer. So based on this, there are different types of definitions which we observe. In all these particular definitions, what we are observing that an embedded system is a dedicated application oriented system. So in order to achieve that particular dedicated application, we need to embed the computer or a software to get that type of application. So like this, similarly, if you see here, so embedded systems are the electronic systems that contain a microprocessor or a microcontroller or a microprocessor based control system which processes a fixed set of programmed instructions. So like that, we have seen that different types of definitions of an embedded system where we can achieve. So from all these particular definitions, what we are observing that in any embedded system, so either you can embed computer or software or microprocessor or microcontroller. So all these particular the units that we are embedded to achieve a control. Basically, people having different opinion that the embedded system means it belongs to a particular domain people. Whether it belongs to it belongs only particularly electronics or computer science like that. So we cannot say like that, but it is actually the embedded system. It is interdisciplinary domain. So I can just the explain the embedded system when you see here, which is associated with the digital electronics. So we can come across various type of digital systems like combination logic circuits, sequential logic circuits. Then we have different types of multiplexers, then demultiplexers, encoders, decoders. So then we have a different types of registers, counters. So all sort of things that we can come across in the case of embedded system. So that's why I can say digital electronics is one area. Then there are the different types of chips will be there. That is integrated circuit design. So where there are different types of small scale integrated circuits, medium scale integrated circuits, there are certain full custom, semi custom, VLSI, like that different types of circuits will be there. And then which is associated with the computer architecture. So basically there are embedded systems, one classification networked embedded systems also is there. So we need to discuss about TCP/IP protocol or OSI reference model, and what are the things. Basically, here in any particular computer architecture, we need to deal with the control path and data path. So depending upon the application, we need to provide the commands to operate this particular data. So in such cases, what we can say is computer architecture also needed. Then we need to have the software engineering. So that's what we have seen one definition. We need to embed this software within a particular system to achieve the control. So we need to deal with software engineering, then data communication, then we have the control engineering, then electric motors and actuators. So these two actually we can observe the applications of automobile engineering. So where in the case of the automobile engineering, so we will deal with the electric motors and actuators and the sensors and the measurements. So these are the two topics, because we will try to see that in coming topics where we can use this particular motor, actuators, sensors and measurements. Then it deals with the analog electronics. So we'll have different types of amplifiers, so then rectifiers, all sort of things that will be there. So an embedded system is a mixture or the interdisciplinary domain where we can come across all these particular domains. So just I'm talking about this type of the areas, but there are so many types of what we can say areas, other areas. Nowadays you are seeing that biomedical instrumentation, or in the case of radar signal processing, or in the case of different applications. Now machine learning data, the artificial intelligence applications. So a lot of applications where we can use this particular embedded system embedded system domain, so to achieve different types of applications. So some examples, very basic examples, as I said that we need to provide the control. So by embedding a particular a computer within a particular system. So please remember that here embedding a computer means it may be a processor, it may be a microcontroller, or it may be a microprocessor, or it may be a software. So all sort of things that will come into picture. So one example, what I'll consider is a refrigerator. So in a refrigerator, basically we will use this refrigerator to lower the temperature by switching on a compressor. So controlling the compressor requires some form of electronic interface, so which accepts the low level input control signal and then converts this to the electrical drive necessary to switch the compressor power. So automatically the compressor should be on and off. So for that, we need some particular controlling device which can monitor this particular comparator. So this process of control can be done by a conventional electronic circuit, or we can do it with the help of a small embedded computer. So embedded computer could be designed simply to replicate the minimalized control process described above. So in order to have this particular compressor control, so we will keep the embedded computer, a chip type insert, we will insert in a particular refrigerator. So this is actually what we can say a networked interaction that we will do it. So the first example is a domestic refrigerator is an example for the embedded system. Similarly, there is a car door. So very different example of embedded system is the car door. If you see here, so there are some sensors. As I said, in automobile system, we will use sensors, actuators like that. So some sensors, some human interaction, and a set of actuators that must respond to the requirements of the system. One set of sensors related to the door lock and another to the window. So there are two actuators, window motor and the lock activator. So if you see here, this is actually, even though if you see the car, this is the right door, then we can see the left door and central control lock. So these are the what we can say the different types of the climate control, driver seat. So each particular unit, control unit, will have some particular sensor. So what I mean to say here it is, so everything, suppose central locking can be introduced or alarm sounded. So when all the doors are closed perfectly, then central lock will close. So if any one of the door lock is door is not closed perfectly, then there is an alarm that comes. And similarly, suppose sometimes if you are not wearing the belt, so even if you are not wearing the belt also, automatically there is an alarm that comes. So that is actually a simple, in fact, that sensor consisting of simple AND gate principle. So AND gate principle means when all the inputs are high, then the output will be high. So suppose when you take the A input, B input, so both the inputs should be high, then only output will be 1. So in such a case, suppose if you are not wearing the belt, so then this input will become 0. So one of the input, that is ignition, the car belt, and then the steering, the what we can say timer. So when these three inputs are not high, then output will be 0. So then automatically we can get a alarm. So what I mean to say is, so we can achieve some control based on the sensor or the actuators. So this is another example. We have seen that a refrigerator, one example, then another one is the car door as another example. So then similarly, the pacemaker is another example. Remotely, doctor can access the person, and then he will control the pacemaker. So this is also another example. See here, a doctor is configuring a cardiac pacemaker inside his patient's chest while sitting 2 kilometers away. Okay, so another person is traveling in a driverless car that takes him from Mumbai to Delhi using this inbuilt navigation program. So similarly, we can see that electronic ping pong game So we observed that. So of course now actually there is recently PUBG game is banned by the central government. So all these type of games developed by using this type of what we can say inserting a chip, and even in the smartphones also we have sophisticated micro chips which are built in a particular smartphone to achieve different types of apps. So in all these cases, we are observing the what we can say that we are observing the applications of these particular embedded systems. So now we can see that the advantage or the application of these particular embedded systems, more than 30% of the cost of the car is now in electronics. That is 90% of innovations will be based on the electronic based on the electronic systems. Okay, so that's why the most of the time the cars nowadays they are actually crores together. So only difference is the novelty, that is the based on the electronics, the cost of that particular car will be increasing. 30% of the car is now in electronics. Suppose if it is a 1 crore car, minimum 30 lakhs, it is the cost of that particular electronics only. So 90% of all innovations will be based on the electronic systems. So these are the different types of controls that we can observe in the case of embedded system. So one is engine diagnostics, display, speed, and even if you see that the uh, the trip calculator. So earlier days we need to trip calculator. We need to what you can say if you want to find out the time uh, uh, the time traveled to a particular place. So we need to we filter that particular tank, and then we need to reset, and then we need to find out the kilometers traveled, and based on these particular kilometers we will know that how much distance it is traveled. But now the trip calculator, automatically we can reset the particular system, and then if you initialize the what you can say the starting point and then destination point, automatically it will give that particular time. So these are actually the processing units which we observe in a particular car seat. So that many types of what we mean to say is how many CPUs in a car seat means here. This many type of processing units that are needed to have a control of the particular system. So this is one example for the interest. I'm showing that front back motion, seat tilt motion, control button interface. So these are the so many CPUs in a car. So you can see that how many Pentiums that we can insert in a particular car. Okay, so that shows the electronic complexity in a car is increasing. So one example of an embedded system is a guided vehicle is an example. So up to now we have seen that a system, an embedded system, and then what are the different types of general applications of an embedded system. Now coming to a specific application is a guided vehicle. So guided vehicle means here, so this particular vehicle which we can drive, which we can move this particular vehicle by programming. So we will write a program, and based on this particular program we can what we can say the interface all these particular devices, and then we can run this particular vehicle. So if you see here, there is a converter called analog to digital converter, then there is a PIC micro controller, and then we have a motor driver interface, and then different types of sensors, bump sensor, light sensor, then we have a power regulation management. So like that different types of devices, the sensors that are there. So this is one type of of what we can say the guided vehicle is an example. So here, as I said, the processing element what people are using is the pick controller. So now most of the time earlier days the people use 8051 microcontroller. Now we have a pick controller, a 32 bit the processor, pick microcontroller people use. And what are the different types of processing units that a embedded system consists? So as we said just now, we are seeing the PIC controller is one type of a processing control. So here different types of processing units of an embedded system. So why we will discuss about the processing units of embedded system is we can have the classification of embedded system based on the processing units also. So number one is the processor in an embedded system is a processor is an important unit in embedded system hardware. So what type of processor they will use? A microcontroller is an integrated chip that has the processor, memory, and several other hardware units in it. So these form the microcomputer part of the embedded system. So microcontroller is one example. Then another one is an embedded processor. It's a processor with specific features that allow it to be embedded into a system. So a DSP processor is a processor meant for applications that process the digital signals. So in order to process the digital signals, example is filtering, then noise cancellation, echo elimination, compression, encryption, all sort of things that we will do it in this case. So first one is microcontroller we will use. Then the second one is an embedded processor. And similarly, we have the application specific processor as a, and then multiprocessor. So we have a multiprocessors are based on the film classification. We have a single instruction, multiple data, multiple instruction, multiple input. Like that, there are four different types of processors are there. In that four different types of processor, we have a array processor, systolic array processor. Like that, different types of processors are there. So we can use any type of processor. So which we can use this particular process to achieve the application. So basically, there are four type of process which we can use it in the embedded system. One is the microcontroller. Second one is the DSP processor. Third one is application specific processor. And fourth one is the multiple processor in a system. Okay. So are you following? Is it audible? Hello?
Yes, sir. Yes, sir.
Hello?
It's audible. It's audible. It's
Okay.
fine.
Yes, sir. Yes, sir. You are audible.
Yeah. So that's what
Okay, sir.
up to now we are seeing that the different types of process that we can use it in a particular system. So now we can go for the so now we can go for the 1 minute. So please wait. There is some. So is it audible, visible the slide?
Yes, sir. Now it is visible.
So that's what there is a okay. So now
Yeah.
coming to the categories of embedded system. So in the case of categories of embedded system, so there are different types of categories that we can have. Number one is the standalone embedded system. Now, keeping in view that depending upon the processing elements, we will have different types of classification. In the classification, first one is the standalone embedded system. A standalone embedded system works on itself. It is a self-contained device. So it takes either digital or analog inputs from it input ports, and it will convert and process the data, and it will display the data and controls. So some example for the standalone embedded system is a simple video game console or MP3 digital camera, microwave, are such typical examples fall into this category. So these are all actually the standalone means we can use it for a domestic purpose. The as I told you that for game player, and then for taking the pictures, digital camera, and woven, all these things will come under standalone embedded system. Second one is the real-time embedded system. So most of the time we are hearing about the real-time embedded system. So when did you say that a system is real-time? So real-time means here, if the response time is critical, a system is said to be a real time if the response time is critical, or in other words, some particular work must be done in a specified time period. So basically, the real time embedded system means here two things will come into picture. So functional correctness and the time constraint must be satisfied. So functional correctness means here whatever the work that we are considering, the output must be correct. So output must be correct, and then not only the output must be correct, but the time constraint must be satisfied. So within a stipulated time, we need to complete that particular task. So there are two types of real-time embedded systems. One is hard real-time, another one is the soft real-time. When did you say that hard real-time? For a hard or immediate real-time system, the completion of an operation after its deadline may lead to critical failure and result in live loss or property damage. So hard real time means immediately we need to complete that particular task. So that is actually within a nanoseconds. In fact, we cannot talk about seconds, but milliseconds, less than that particular milliseconds. If you complete that particular work, so then we can call it as a hard real time. So these systems usually interact directly with the physical hardware instead of human being. So an example of hardware, hard real time, most of the time people give this example, car airbag control system. It's a hard real time system because the delayed reaction may cost driver's life, and the delay response in a hard pacemakers will also lead a severe result. So that's what actually, suppose a particular accident that occur. So immediately that airbag should open. Suppose if it takes 15 minutes time, then the dead body will come into that particular airbag. So that's why, so the time is very important. At the same time, the function also should provide the exact output. So these two the aspects are very important in the case of real time: functional correctness and then the time constraint. So these two are very, very important in the case of what we can say hard real time embedded system. Similarly, the soft real time embedded system, some other embedded systems, there is a response deadline, but the lateness can be tolerated in some degrees. So violation of time constraints will result in a degraded quality, but the system can continue to operate. So microwave and operate washing machine fall into this subcategory. There is a response time deadline for any operation. The allowed latency delay can be seconds rather than milliseconds. So this is actually what we can say the microwave and the washing machine fall into this category. So then so that's what in the soft real time we need not worry about the timing aspect. Okay, even if it takes some time, there is no much difficulty, because suppose in a oven, if you keep some particular item, so because of some particular delay, if it instead of 3 minutes, if it take 5 minutes, so normally we can heat that. So there is no the timing constraint, but of course the functional correctness should be needed. But even if you elapse some particular time, so we need not worry much. So that is actually soft real time. So the first one is standalone embedded system. Second one is the real time embedded system, where in the case of real time embedded system, we have a hard real time and soft real time. Then third one is, as I said, networked embedded system. So networked embedded systems are connected to network with network interfaces to be accessed or to access other resources. So the connected network can be a local area network, wide area network, or internet. The connection can be wide or wireless. You can simply group the networked embedded systems into wide or wireless subcategories. But in many systems, these two type systems are merged together. So here, as I said, a home security system is an example, a LAN networked embedded system where all sensors like press sensor, light sensor, or a smoke sensor are wired and running on the TCP/IP protocol. This is actually four-layer protocol, and a home security system can be integrated into a web-based security system with additional web camera running on HTTP protocol. So networked embedded system is the third type of embedded system. And this is actually the three different types. And then based on other mode of classification of embedded systems are the based on the small scale embedded system, medium scale embedded system, sophisticated embedded system. In the case of small scale embedded system, these systems are designed with single 8-bit or 16-bit microcontroller. We can have the small scale embedded system. Then medium scale embedded system is, these systems are usually designed with a single or few, that is 16 or 32-bit microcontrollers or DSP or reduced instruction set computers. These have the both hardware and software complexities. So this is actually the medium scale embedded system. And then third one is the sophisticated embedded system, where the sophisticated embedded systems have enormous hardware and software complexities. So and may need scalable processors or configurable process and programmable logic arrays. So these programmable logic arrays will come under the programmable logic devices. So that is actually another category in the case of programmable logic devices. So these programmable logic devices, just I'll give some idea about programmable logic devices. So earlier we have a fixed IC, that is multiplexer, demultiplexer, like that. So simple fixed ICs will be there. Then afterwards we have a application specific ICs. Then after application specific IC, we have a very large scale integrated circuit. Then afterwards we have a programmable logic gates. So where so many number of gates we can fabricate on a particular chip. Then afterwards we have complex programmable logic device. In the programmable logic device, we have a programmable read-only memory, programmable logic array, and the programmable array logic. So all these things will contain huge number of gates which are incorporated on a particular single chip. So that is actually that type of chip where the thousands of gates are built in a particular single chip. So that type of processor, if a particular embedded system contain, then that is called sophisticated embedded system. So small scale embedded system, only single 8-bit or 16-bit microcontroller. Medium scale embedded system is 16-bit or 32-bit microcontroller. Or sophisticated means, so as I said, PLA, PAL, programmable logic device oriented chips that we can use. So that is about the classification of embedded system. Two different types of classifications which we have seen now. So now coming to the embedded, what we can say, embedded system, the configuration. So typical computer system configuration and the embedded system configuration. So in the typical embedded system, typical computer system configuration, normally we have a operating system, hardware, and then corresponding the programs will be there. But in the case of embedded system, we have the hardware and associated with the user program, operating system, components, all are there in a particular the system configuration itself only. The operating system, hardware. But here only two parts will be there: hardware and associated the user program, the operating system components. Now coming to the example for the typical embedded system, this is actually any general purpose, the application when you consider. So let us consider a simple guided vehicle, as I said, an example for embedded system. So basically here, depending upon the application, we can have, we need to write different types of algorithms for digital control. Then there is a data logger will be there. So this is actually in order to use data, we will connect, and then data retrieval, operator interface. So then remote monitoring system. Then we have a real-time clock. Then algorithms for digital control. Different types of algorithms which we can develop either using embedded C or different types of programs that we can use it. So these are the different blocks. Any typical embedded system which we can have. Suppose a temperature monitoring control that we need to do. So we need to take the data, analog data, and then this particular data. So in order to process this data, the corresponding program which we need to do, and there is remote monitoring system, so which is connected to a particular system. So this is actually the one general purpose application. So coming to the embedded system, what are the different types of the components that will consist? The basically three basic components any embedded system we have. One is embedded hardware. So that is similar to the simple example. I can say that the ROM or a flash memory. Then the second one is the main application software. So where the main application software may concurrently perform series of tasks or processor or threads. And then third one is the real-time operating system. So we will see the real-time operating system afterwards. So these are the three things that will be there: and hardware, application software, and real-time operating system. So these are the three basic components in embedded system. So this is one the typical picture which we can have in the embedded system hardware. So we have a processor, timer, interrupt controller. So different type of parts which we can have. So this is actually the suppose if I take a simple example. So just now, as I said, suppose if you want to monitor the room temperature, so we have a different sensors which we can connect, and the analog input, that whatever we are considering, that is converted into digital with the help of analog to digital conversion. So in the case of analog to digital conversion, we will use different types of A to D converters, and then after getting that particular digital output, so that is fed to a central processing unit, and from the central processing unit, that particular digital input, so we can apply software, and then we can process. We can have a memory, then we have a FPGA ASIC, and then a digital to analog conversion, and then we have a actuators. So like this we can what we can say that we can use all these particular what you can say analog to digital conversion, digital to analog conversion. Then we can connect the actuators, and then electromagnetic and mechanical backup and safety external environment. So all these particular things that we can observe in a typical embedded system organization. So FPGA ASIC, memory, CPU, DTA conversion, actuators, all these particular what we can say the components that a typical embedded system which we can typical embedded system which we can consist. So mainly these are the components of an embedded system consists. So general purpose microprocessor, then application specific, as we have seen that multiprocessor. So see, this is another version. So I'm not touching these things because microprocessor are microcontroller. So these are actually everybody familiar. Microcontroller. Just for the reference sake, I'm showing these things. So these are different types of components: power source, clock oscillator, system timer, so a reset circuit, power up, so memory. So input, output, and I/O ports. DAC using PWM and ADC, LCD, LED, keyboard, interrupt handler. So these are actually the. Is it audible? Is it audible? Hello? Hello? Hope it is audible, everybody. Hello?
Yes, sir, you are audible. Sir, you are audible, sir.
Yeah. So that's what.
Yeah.
So that's why I'm showing all these things actually. So now you can see that online teaching is not that easy. So give a class which can impact to the people so that we can have some time. But here it is very difficult to continuously talking. Also, it's not easy. Okay. Now coming to the embedded system development. This is actually I want to develop the embedded system in a real-time operating system. We need to have a workstation. Then these are the different types of embedded systems and signal source, the other test harness. So like this we can develop. And coming to the metrics for embedded system. Now from here onwards, I'll try to discuss about matrix for embedded system, and then we can discuss some characteristics, and then afterwards how to design a particular embedded system, two examples. So with that, I'll try to complete. So quickly, I will try to discuss about the metrics. So there are different types of design metrics are there. One is the power dissipation. So battery operated systems power is important for mobile phone or a digital camera. The performance, instructions execution time in the system measures the performance. Then processor deadlines. Then user interface, size of the system is measured in terms of physical space required. So these are actually the what we can say the power dissipation, performance, processor deadline, user interface, and size. So these are the design metrics. Then engineering cost, manufacturing cost, flexibility, prototype development time, time to market, system and user safety. So maintenance. So these are actually the metrics for embedded system. Now coming to the characteristics of embedded system. So in the case of characteristics of embedded systems are designed to do some specific task. So they should perform some specific task rather than a general purpose computer for multiple tasks. Then embedded systems are not always separate devices. Most often they are physically built-in devices they control, as we have seen that embedded in a particular system to have a control. And the software written for embedded system is often called firmware. So the software written in embedded system is called the firmware. and then must be dependable, then maintainability, availability, safety, and security. So these are different types of characteristics of an embedded system. Then it should be must be efficient, cost efficient, dedicated towards certain applications, dedicated user interface. So because, so suppose if it is not user interface, then we cannot perform. So then frequently connected to the physical environment. So these are certain constraints, even though they are the design metrics, but these things which we can consider as a constraints also. So that is actually, these things will come across, we can say that a prototype model, a small size, low weight, low power, harsh environment, soft critical operation, extreme cost sensitive. So this is actually how we can write a software in a system. So an embedded system processor executes software that is specific to a given application of that system. The instruction codes and data in the final phase are placed in the ROM or a flash memory for all the tasks that are executed when the system runs. So this is actually the system ROM memory embedding software, real-time operating system, data, and vector address. So this is actually like a stack pointer, how we can perform the push and pop operation. So here also in embedded system, we can write this particular software that is called the firmware. Different types of program models for software designing. So the program design task is simplified in is a if a program is modeled in a particular model. One is sequential program model. So these are the things that we can observe in the case of VHDL. So there are different types of models like structural model, the what we can say data assigned model, then object oriented model, behavioral model, like that, different types of models which we can use it. Similar type of the models which we can develop: sequential program model, object oriented model, then control and data flow. Here the control and data flow graph model, which we can use it in the a data flow model we can use. Then finite state model, which is again the based on the sequential methods. So in the case of finite state, by using the state diagram, I think you are familiar with the finite state machine non-deterministic and deterministic models. There we can use this particular finite state model, and then multi-threaded model. So like that, different types of program models which we can use it in software design. These are the different types of models. So this is actually we can discuss in the case of hardware software co-design. In the case of hardware software co-design, we can come across these models actually. So that's why I'm not touching these models. Actually, we need to discuss there actually. So there are certain tools, software tools for designing an embedded system. One is editor, interpreter, compiler, assembler. So these are the different types of tools that we can use it: cross assembler, simulator, source code, engineering software, stethoscope. So these are the different types of software tools people use. And then these are the common types of embedded systems. So now coming to the operating systems for embedded systems. So there are two types of operating systems. One is real-time operating system, are operating systems which guarantee response to each event within a defined amount of time. As we have seen that software, soft real time, hard real time. So some commonly used RTOS or embedded systems are VxWorks, OS9, and RTL Linux is example real-time operating system. Non-real-time do not guarantee defined response time. Those systems are mostly used if multiple applications are needed. So Windows CE and Palm operating system are examples such operating system. So normally the people use the real-time operating system. Then embedded system design involve hardware and software design, software for flexibility, hardware for speed. So co-design, as I said, different types of hardware software co-design, because the normally traditional method individually people design, but that is without having the concurrism. But here we can assemble, and parallelly we can design the hardware as well as software. So these are the design requirements. If you want to design an embedded system, we need to check the timing aspect, power consumption, cost sensitivity, size and weight, safety and reliability, time to market, and others. So these are the, again, as we have seen. So these are the design challenges. So when you want to design an embedded system, so it should provide the long life cycle, reliability, correct functioning is crucial. That is safety, critical application, and damage to life, economic, and result. Then real-time systems require not only the right output but at the right time. Imagine a delay of few minutes, as we have seen that hard real time, a few minutes delay also it will give more damage. And they are the concurrent systems. Okay. So they must be reactive systems, that is continuous interaction with the environment. So these are the six resource constraints are the design challenges. It should be compact, the simple processor, limited memory, quick response, good throughput, and low power. So if you want to design any embedded system, these are the design challenges that we need to achieve. So this is actually the design process, very important thing. So if you want to design a process for embedded system, the first one is abstraction. Each problem component is a first abstracted. So suppose if you want to design a robo system, the problem of abstraction can be in terms of control of arms and motors, and hardware and software architecture. Architectures should be well understood before design. So then extra functional properties, then system related family of design, modular design. So that means the entire system is divided into modular design concept should be used. System designing is a fast decomposition of software into modules that are to be implemented. Modules should be such that they can be composed later. So we need to divide the entire system, decomposing into different modules, and then we need to design. Then mapping into various representations is done from software requirements. For example, data flow in the same path during the program flow can be mapped together as a single entity. So first one is the abstraction, hardware, software architecture, extra functional properties, system related family of design, modular design, mapping. So these are actually the user interface design refinement. So these are the design process steps that are involved in a embedded system. So I'll show that examples. So these are the different types of examples of embedded system: telecom, smart card, missile, satellite, banking, telephone, then like that. So one example is automatic chocolate vending machine. So this is actually the blocks that contains a keypad for user interface, mechanical coin inserter, real-time operating system, embedded software, LCD display, microcontroller based hardware, then chocolate and refunded coins collection board. So this is a one example, automatic chocolate vending machine. So we need to design such thing. What are the software components, hardware components that we need? So we need to have these particular components, a keypad, LCD display, as we have seen all these particular things, coin insertion slot, then delivery slot, interconnect connection. So once if we have all these things, then there should be some particular functions. What are the functions? It should display welcome message, and it should take the borrow and all those things. Then hardware components, in order to design this, we need to have a microcontroller, RAM, flash memory, timer and interrupt controller, TCP protocol, power supply. These are the hardware units that we need to have. Then software components is keypad, display task, read coins, delivery chocolate, TCP. So like this, we need to have software components. So once if we have all these things, we can design the embedded system. Like that, automatic chocolate vending machine we can do. Similarly, mobile phone hardware units. What are the hardware units? We need to have the mobile phone system microcontroller, DSP core, flash memory, peripheral circuit, LCD controller, battery. And then software components, operating system, Java, memory, keypad, all sort of things that we can have. So here software components, mobile browser, simple camera, Bluetooth synchronization, all these things which we can have. So in addition, phone, mobile computer has the following software components: operating system, touch screen, memory stick, Outlook application, like this. Okay. So these are the two things. And then typical embedded system, flight control system. There is an autopilot controller, inner loop controller, airframe, dynamic system. So these are the examples. So this is actually engineering view of embedded system. And suppose if you want to design, so these are the two examples, as I said. One is automatic chocolate vending machine. Then how we can do it, hardware units, then software components, and then we can design that. So you can incorporate this with the help of your students. You can make them to do that particular simple design. Similarly, mobile phone is another example, as I said. And then this is flight control system. Of course, this is a bigger one. In the defense system, people use different types of modules by using the embedded system. So this, like this customer view, we can observe. Then how design can be done using FPGA. Then why we will go for FPGA means to get the reconfigurability software design thing. Okay, so this is the how we can interface robo with FPGA. So we can interface the robo with FPGA. So these are the different what we can say, the job opportunities in the area of embedded control. So we can go for a hardware design, software design, and device driver, kernel developer, network engineer, RTOS program, software engineer. Okay, so like that we can use it. So this is actually the, as I said, FPGA based means we can have a, normally it's pattern kit that we can use it. So once if you have this particular robo, so for the design of this particular robo, we can write a code in VHDL. So either we can write the program in a structural model or the behavioral model, or we can say that data flow model. So we can write the program, and then there are certain interfacing drivers which we need to have the system, through which so we can have the FPGA. There is a Spartan kit. So normally this is the Xilinx version is there. There are different types of Spartan kits are there. We can use these particular kits, and we can interface this FPGA with the robo. So these are different types of job opportunities which we can have. Of course, so if any students are there, so you can go for a hardware design engineer, software design engineer, device driver developer, kernel developer, RTOS programmer, like that. So these are the companies they are working in this particular embedded system. So that's all about hello.
Yes, sir.
Yeah. So any clarifications or any questions, please?
Yeah. Participants, have you any questions? Then please ask. Hello, participants. If you have any questions, then please write on the chat box. There is no question, sir. Thank you, sir, for this
Thank you,
valuable session. Now there have some questions, but there is no questions. So now I would like to request Mr. Pallav Datto to present a token of appreciation to sir. Hello, Pallav. Pallav. Yes. Sir, there is one question. Hello, sir.
Yeah.
Moinak Mukherjee is asking IoT-based controller design for distributed generation.
That is actually related to this topic I am asking. That is distributed generation. There is another topic, I think.
He wants
Distribution.
to share related resource.
Yeah. Different type of. I think I saw in your schedule power distribution. Yeah, that is different domain actually.
Different domain. Yes. Yes, sir. So I'm requesting Paulo to present a token of appreciation, and we will sending it by email, sir. Also, okay.
Okay, madam. Okay, thank you.
So Paulo, sure. Hello, Paulo. Are you there?
Madam, I'll take a minute of time because my WhatsApp is not connected over here. I'll take minute time. I'll just connect the WhatsApp and I'll show the token of appreciation to sir.
No problem, madam. No problem, madam. Okay.
Okay. Thank you, sir.
Thank you. Thank you. I will send my details, madam. So I
Yes,
think
sir.
you can send a mail. The other details I'll send it as you asked,
Okay.
na? Okay, madam. Thank you.
Okay, sir. Now we will go for our next session. But next session will start from 12:30. Okay. Please wait for some time.
Madam, can I show now? Hello?
Hello, I think Sam has already lived.
Okay.
Okay, then you send him to by mail.
Okay, okay.
Okay. Our next
Okay.
session will start from 12:30, na?
Yes, madam.
Yeah. Speaker has not arrived till now.
Hello,
Good afternoon, madam.
yeah,
Good afternoon. Yeah, welcome to our session STTP Phase 3.
Yeah, thank you, Rupa.
Thank you, ma'am. Okay, please wait for another participants. Ma'am, please wait for 1 minute, please.
No problem. No problem.
Mhm.
Let the participants come, then we'll do.
Ma'am, can we start the session? I think they will. Hello, ma'am.
Yeah, no problem.
Okay, then I am introducing. Good afternoon and welcome to everyone present here. Now we are entering towards our second session of today. Today we have Professor Dr. Celia Sehnaj as our honorable guest for the second session, and she is already with us. It will be my privilege to introduce our honorable speaker. Celia Sehnaj is MIEEE Fellow IEB, received PhD degree from Concordia University, Canada, and is currently a professor, Department of EEE BUET, Bangladesh since 2015. She has published more than 150 international journal or conference papers. She is a recipient of the Canadian Commonwealth Scholarship, Fellowship and Bangladesh Academy of Science Gold Medal for her contribution in science and technology. Recently, her papers have received Best Paper Awards in Biomedical Engineering tracks at 10Con 2017 and at IEEE YCon ECE 2016, that is 2016. In Humanitarian Challenge track at R10 HEC 2017. She was the mentor of first and second prize winning projects in IEEE IAS CMD contests, robotics and humanitarian in 2017 to 2019 USA. She was the supervisor of 4th and 5th rank winning teams in SPCUP competitions, ICA SSP 2020 Spain, 2015 Australia. She is the recipient of 2019 R10 Humanitarian Activities Outstanding Volunteer Award, 2016 MGL Leadership Award, 2015 WIE Inspiring Member Award, and 2013 R10 WIE Professional Volunteer Award. She is the chair, IEEE Bangladesh Section 2020. Member, IEEE New Initiative Committee 2020. Chair, Women in Site Working Group 2020 to 22. Member, IEEE Signal Processing Society SPS. Women in Signal Processing Committee 2020. Member, IEEE WIE Senior Member Elevation Drive 2019-20. Member, IEEE WIE Subcommittee 2017 to 2020. IEEE Region 10 Regional Representative 2017-2019. Communications Chair, IEEE Site Steering Committee 2017-18. Chair, IEEE WIE Workshop Subcommittee 2017-18. Member, IEEE Region 10 Subcommittees, WIE Humanitarian Technology Activity Education. 2016 IEEE Region 10 WIE Coordinator. General Chair, IEEE 10 SIMP 2020, IEEE SpiceCon 2019, IEEE PIACon 2019. General Chair, IEEE YCon ECE 2019, 2018 and 2016. General Co-Chair, IEEE Region 10 HTC 2017 and IEEE YCon ECE 2017. Founder and TPC Chair, IEEE YCon ECE 2015, IEEE BCthon 2019, IEEE RIACon 2019, 2018 and 19. Member, Technical Committee, Image, Video and Multimedia, Asia Pacific Signal and Information Processing Association 2018. Editorial Board Member, IET Signal Processing. Founder and Chair, IEEE SPS IAS Bangladesh Chapters, Co-Founder and Vice Chair, IEEE RAS SSIT Bangladesh Chapters, Founder, Advisor, Nominations and Appointments. Chair, WIEAG IEEE Bangladesh Section. She has around 20 years of experience, more than 18 years as an IEEE volunteer, of leading impactful technical, professional, educational industrial, women empowerment, and humanitarian technology projects at national and international levels. So, welcome, ma'am, in our STTP Phase 3. The session is all yours.
Thank you. Thank you, Rupa, for a humble introduction. It's a great honor
Thank you,
to
ma'am.
be here. So let me share my presentation. Shared, yes.
Women. Women.
I hope you can see it, right?
Yes, ma'am.
Okay. So it's a great honor to be here. So I really work in interdisciplinary area. I apply my signal processing and machine learning and deep learning knowledge in different areas like speech, image, video, and power signals. So I really thank the organizer for taking such initiative. Thanks to Dr. Navamita and Rupa and all organizers. Today's topic is very interesting in a sense that it covers a different domain, and it's related to a very interesting application like location identification using power and audio data based on temporal variation of electrical network frequency and its harmonics. This is my brief bio. Actually, what Rupa has said, I have been serving around 20 years and more than 18 years as an IEEE volunteer. And I'm founder of, as Rupa said, many technical society chapters. I really encourage you to be part of IEEE and, of course, to be part of IEEE technical society chapters to know about the initiatives of travel grant and research scholarships and world-class magazines and technical journals. So these are aesthetic benefits. Thank you. And I really believe in power of networking and innovative ideas. Actually, this is two international day celebration. One is PES, Power and Energy Society Day, and another is IEEE Day by Women in Engineering Group of Bangladesh. This is a human chain of graduate student, PhD student, undergrad student, entrepreneurs, sponsors, executive committee members, advisors. Okay, and this is not just a human chain to me. Actually, it is a network that actually I have utilized for my research. And for any research, actually, I try to connect with one of the UN Sustainable Development Goals, and like no poverty, zero hunger, good health, quality education, gender equality, clean water and sanitation, sustainable cities and communities. So actually, uh, our power and energy area is related to many of these sustainable development goals, and the most important thing, since I'm serving as a IEEE PES Power Energy Society Women in Power Region 10 representative, then I had the opportunity to connect with many members and inspired them for doing research in direction. I will request all of you to just Google me and write my Google Scholar citations. So I will request you to visit my Google Scholar citation to give you an idea that from 2013 to 2020, we are at the middle of 2020 until um, how we are moving in a good direction. That means our citations are always increasing, and we are doing some meaningful research, and the research is cited by others. This is important for young generation, young PhD scholars, that how to make choice of your good topic. This is the best cited paper in my life, and also this is an article transactional speech audio and language processing, and as also transactional speech audio language processing. Let me focus on today's work, electrical network frequency. It is the supply frequency of power distribution grids, actually, ENF, which has nominal value of 50 hertz in most part of the world and 60 hertz in North America. It can be defined as F0, the set point frequency, plus minus the deviation between the instantaneous frequency and the set point frequency, and the deviation range is plus minus 0.05 hertz to zero point 0.2 hertz. Actually, ENF data extracted from power grids vary due to difference between power demand and supply in various locations. And how the ENF are captured, if we record digital audio, or if digital audio recorders that are plugged in power mains or are located near a power source, then it can capture the ENF signal. This is due to interference from electromagnetic fields originating from the power source. Another can be acoustic hums or mechanical vibration produced by electrical power devices. So these are the reasons that ENF is embedded while a digital audio recorder is connected to the power mains or located near the power sources. Now, how ENF is useful? ENF is can be used as location fingerprint. Like our fingerprint when we pass the airport, it gives us our identity. Similarly, this ENF can also serve as a fingerprint of the location of a person. So ENF variations hold some recognizable patterns of a specific grid. The variations are considered to be uniform for a particular grid, and the variations, minor differences are also observed in different locations of the same grid due to critical pattern of power demand and supply. And variations are separable from grid to grid due to different degrees of control mechanism used to control load imbalance in respective network. That means for the same grid, wherever located, or different location of the same grid, the ENF signature remains the almost same. And of course, ENF signature varies from grid to grid. That in that way, actually, if a voice or audio is recorded, and then from this captured ENF, we can have an idea the audio is recorded belong to which grid, and that can identify the location of the person who has provided the audio record. This is very important in security application. There are previous recent work, although not many has done, but now we need to know how ENF looks like. Yeah, from this time domain picture, when y-axis is ENF and x-axis is number of samples, we can see that grid A to grid I are plotted. And from the visual observation also, we can see that there is a remarkable variation. But sometimes it is not possible to identify this variation by eye observation only. That's why such machine learning and feature-based techniques are used to automate the process of classifying the ENF of different grades, what we have proposed algorithm, and we have extracted the ENF and its harmonics. Not only that, we have observed that ENF and its harmonics has slowly and fast varying components. So we have also decomposed the ENF and its harmonics into slow and fast varying components. And from the slow and fast varying components, we have obtained different statistical features. Once this, it is a very difficult problem in a sense that it is not a two-class classification problem. It is a, actually I should say, 9-class classification problem, tough problem, because our recording from 9 different countries are considered in the database. They are named A, B, C, D, E, F, G, H, I, as shown in the ENF plot before. So signal length is very long, 6 to 8 hours, and sampling frequency is 1 kilohertz, and there are 360 hertz grid, that is from North America, that is ACI, and rest of the others contain 50 hertz signals. So we have also tested the different types of grids having 60 hertz and 50 hertz. So this is important. And how we have extracted the ENF, there are different ways of doing it, non-parametric and parametric approach. Non-parametric approach are easy to compute, but it has it lacks in accuracy. So we decided to do spectrogram based method, so that it is a parametric approach and it has some advantage. It provides high accuracy resolution in analyzing the ENF function. Not only that, when we are using music or spirit, this type of algorithm, and actually they are found in the literature to be found effective for ENF signal, because ENF signal dynamic range of frequency fluctuations is quite small. That's why this music and spirit, this type of algorithms are found more effective for extracting the ENF signals because of its less fluctuation. And this root music algorithm is used because another 2 reasons is accurate estimation with the increase of temporal resolution, and also it reduces computational power because decision making should be very faster and it can be easily implementable. Currently existing technique that we can see in the literature that can extract ENF only, but ENF can be found also in the integer multiples of the base frequency. It is observed in literature. So since I had published a transaction on pitch estimation, fundamental frequency estimation in IEEE transaction, that has actually provided me an idea or knowledge to find ENF from integer multiples of the base frequency also. So with that motivation, we have extracted ENF as well as its harmonics from a band limited power and audio data. Band limitation is very important. And we must also see how the harmonics of ENF looks like. We have seen before how ENF looks like. And now for ENF of harmonics from grid A to grid I, you can see also from by visual observation. And there is a remarkable difference from grid A, between grid A, grid B, different from grid to grid. And that gives us a hope that we can automate the process and we can do the machine learning. This is just a simplified identification scheme of grid location. we actually extract ENF and harmonics of ENF using um, using machine learning, using root music algorithm, I should say. Using a root music algorithm, then we have decomposed the ENF, decompose the ENF into slow and fast varying component, and then fast varying component. Then we have extracted features, and then train the classifier model. And using the model, we can detect the grid location. This is just a schematic outline for the others, and it has been observed that then extracted ENF waveform as has two very distinguishable segment, as I said before. The less variable portion, which predominantly shows very low resolution of changes, it is called low frequency. Other segment, that is highly fluctuating portion, which varies, that is called that is called as high frequency fluctuating component. We have extracted already the ENF using the root music algorithm. Now, if you can find the low frequency segment from the ENF, and if we can subtract the low frequency segment, we can also get the high frequency one. In this way, decomposition can be done on the ENF signal, and similar decomposition can be done also on the harmonics of the ENF signal. Now, let us see our feature, which is very important. What is our systems that we consider? We consider power data and audio data. For both power data and audio data, we have used 60 Hz and 50 Hz. You can see on the first column. In the second column, you can see power data, and for audio data, there are several features are proposed. Like for power data, waveform length of low frequency ENF, mean of entropy of high frequency ENF, peak factor of low frequency ENF, median of low frequency harmonics ENF, log of harmonics ENF, waveform. So these are the different features we have proposed, and you can see in the third column the formula for calculating those. It's not tough. And for audio data, we have actually considered signal power of harmonics of ENF, autoregressive parameter of harmonics of ENF, peak factor of low frequency ENF, mean of low frequency harmonics of ENF. So these are the different features we have proposed and found effective for this. Of course, the features from power data and features from audio data are different, because not same feature can be applicable for power data and audio data. That's why we have investigated that which features and which parameters or which attributes will be better for distinction between grid to grid, and can identify the location in the same grid in different locations. Now, after finding the features, we can send it to the classifier, and actually we have we have employed different kernel functions, and you see medium Gaussian and quadratic kernels provides better results. That's important identification to know, to investigation. And previously, we have to compare our result with ENF and decomposed ENF. Previously, ENF is used only. But in our case, instead of only ENF, we have also used the features of low frequency and high frequency ENF. So we can see for both power data and audio data, accuracy using ENF and accuracy using decomposed ENF. And the result shows and justifies that it is rational to decompose the ENF, because it gives better accuracy almost in all systems. Okay, and now we analyze the harmonic components of ENF as well as incorporating ENF harmonics, and we can see accuracy with ENF and accuracy with harmonics. You can see previously we have seen rather than only ENF, how decomposition of ENF gives us a better result. Now my question is, instead of ENF, how harmonic CMF is giving better accuracy. That means we are finding our rationale to use harmonics of ENF rather than using only ENF. And now you can see overall accuracy of the existing method, of the proposed method, and you can see that we are doing better compared to others. So now you can see for a confusion matrix for a 50 Hz grid, and you can see the y-axis is the test class and x-axis is the detected class. Almost everywhere we got 100%, but in case of E and D, there is a problem. When D is tested, you can see it has 33% time it is detected as F. When E is tested, by 33% time it is detected as D. But you can see for confusion matrix of 60 Hz grid, it is almost always 100%. That means we have some summary that can be used to help the security application. That means decomposing the ENF improves the accuracy. And using the features of ENF harmonics also increases the accuracy. So detection accuracy is less in audio data because audio data can be susceptible to low signal to noise ratio, SNR. And detection accuracy of 60 Hz grid is higher than 50 Hz grid. It can be concluded that in North American countries, the fluctuation of electrical network frequency is less random. So whenever a test audio or power data or a record is coming to us, and if we are asked to identify that from which grade it is coming, then it will be easier for us if we can come up and follow the result. Then it will be easier for us to find that which grade it belongs. It is a very important work, I should say. It's opened up a new direction of handling grid data through power or through audio data. And this is very important. And conclusion, fluctuation of electrical network frequency can geolocate a country's grid. It's very important statement. And adequate database or a big data, if collected, then it is also possible to detect smaller region within a grid. Then we can also identify not only the country, not only the grid, we can also identify which state of India or which city of Dhaka, which city of Bangladesh is belong to. But we need a big data. Further investigation on such signal with vast data from more countries will help us achieve higher performance in detecting location of media signal without relying on real-time GPS data. This is a very, very important conclusion. Okay, so we need data from more countries, and that will help us to identify the media location, because there are many times you can find that some audio is circulated in the social media and you don't know who is speaking and from where it is speaking. So that's why we can detect the location of media signal without relying on the real-time GPS data. We can use the power grid data and audio grid on audio data to identify the grid's location, and also indirectly it will give you the location of media signal. That is a very emerging technology. These are some references for your kind information. I must now, since it is a pandemic, I must now relate power and energy, society, or related activities to humanitarian technology. Let me give some examples of humanitarian technology. Non-polluting lighting, heating, and cooking method, technologies for clean water and sanitation, off-grid electricity generation like solar, bicycle, agricultural technologies like irrigation methods, and I work lot of I work in a lot of project for healthcare technologies because it is now pandemic, and since Bangladesh is affected by disaster always, the floods and other. So as an engineer, we felt different initiatives to take, and one of the example is shelters with appropriate technologies for better protection against disaster and energy crisis, because during the disaster and during the energy crisis, it is we really need to have the appropriate technology for their better protection. And I'm suggesting you to visit IEEE philanthropic programs like IEEE SITE, Special Interest Group on Humanitarian Technology. I know Kolkata, Zawad Siddiqui is the IEEE SITE group chair. You can also communicate with him. And I'm the SITE communication chair. I served for 2 years for 10 IEEE regions. That means for the whole world. Now for the whole world, I serve as chair of Women in SITE working group. And I will request you to visit their website, Facebook page to see the project calls from 20,000 to 60,000 US dollar are funded, and there are also different event. You can also be funded from event related to humanitarian technology. Now, actually, let me share some factors that controls the future trends in power and energy. As you can visit IEEE PES e-news update. It's a very amazing, I should say, e-news to get news about what is happening in the technical area of power and energy society. Actually, there are three factors: energy storage and integration of renewables, distributed generation and hybrid mode of grid, and data-driven technologies and cyber security. So it is clear that in my presentation I have targeted data-driven technologies and cyber securities. That means I'm in one of the three major future trends in my research group. That is very important for us to know. And now how we will utilize renewables. And then you see the solar panel can be used for irrigation, can other purpose, and also there are in IEEE or in India, Pune has been considered as one of the smart cities. Another is Ajmer. So these cities actually what they do, they collaborate with IEEE smart city initiatives, and they use renewables for home automation, for curtain control. This is smart home actually, for lighting control, curtain control, then office automation by ICT and connectivity, and remote maintenance or security and surveillance, and digital media center and car parking management system. These are all part of power and energy, and actually it can be done. It can be done, and it can usually give a great example of using the renewables. And there is another how we can do alternative energy utilization. You can see that how a bicycle can be run, how the roads can be used for different energy utilization. And this is, I should say, some funding opportunity, lighting for humanity. This is Power and Energy Society and IEEE Humanitarian Activity Committee. They have a lot of funding, because think about our children or our students who are not in the hostel now. We have sent them back to their home, and we are expecting that they will be joining our online classes. But you know, they have suffered. They don't have, many of them do not have light. If you consider the rural part of Kolkata or West Bengal. You think about it. Although we have progressed a lot, we made a lot of improvement in Bangladesh and Kolkata, but still there are a lot of underprivileged community, and many of our students are living there. This is our time then when we think about power and energy society and humanitarian activity to approach them so that we can implement such projects for the underserved so that they have minimum lighting or minimum internet connectivity when it is required. And this is girls, we need to train our young girls that how to implement a solar panel so that those solar panels can be implemented in every rural home for at least one study table, or every rural community to have uninterrupted operation of a pregnant woman, or for preserving the insulin is a basic needs of many people. So we can actually have our women or girls to do such projects. Okay, and not only that, I talked about community clinic. Here you see her, you have a Georgiatic student. They have done electrical power, a hybrid microgrid system for a Haitian health center. So we really don't need to parachute to Haiti to do some humanitarian technology. In Bangladesh, India, Pakistan, Sri Lanka, and other countries, region 10 countries, we have lot of needs to do and do such our knowledge to employ our knowledge to do such projects to help the community. And we should take it as our advantage and privilege and opportunities to serve the people and utilize our research. And I work in IEEE Smart Village, officially working in a South Asia, also in the global IEEE Smart Village. And you can see how the Smart Village are supporting schools, fans, TV, clean water, agriculture, street lights. So we can, IEEE Smart Village has done a project in Ladakh for a electrification. You can see the top row in the middle picture. It is a picture of Ladakh. And it's very amazing that how those solar panels were implemented there in such a height, and it has light up a huge community where there is no light. And that's very important. It is in Bangladesh. Actually, we have many roads. Also in Kolkata, I have visited so many times. My grandfather was a lawyer in Kolkata in the British era, 50 years back. And every year I visit Kolkata. And I have seen in both the countries there are a lot of narrow streets where ambulance cannot go. Think about a pregnant woman, how what she needs support, and an elderly person if he wants to go to the doctor or has some medical emergency. So this type of solar based 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 uh, ambulance is very effective, where we can utilize our knowledge of, and this is from Madras. We have a Bay of Bengal and a lot of fishing industries, and the boats are going to the seas, but they need support from the solar, so that they have the lights, they have can charge their mobiles, they can drive their engines, they can drive their fans. Not only that, when they return from the sea, most of the fishes are, I should say, that they cannot preserve it. So what we can do, we can empower a social entrepreneurship. We can empower our women by provide a bike driven by solar energy, so that they can vendor it in the nearby areas, and if our social culture permits it, because it's important. And now it is COVID-19. I will request all of you to engage your young generation to do something related to automatic hand sanitizer, so that it needs power. And also, not only that, even if the pandemic is over, you can deploy those sanitizers to the rural villages, schools where they have no soap at all. So this is my some contribution in Region 10 flagship conference in Bangladesh. I was general co-chair, and also humanitarian technology conference where I really trained women and shared my idea about the projects, how to involve more women to advance sustainable green technologies for humanities. And also I work with IEEE SSIT, Society on Social Implications on Technology, where in Australia, in a flagship conference of SSIT, I have conducted a Women in Engineering panel where I actually collaborated and listened to the presenters from USA and Australia to know the best practices so that we can implement it in Bangladesh, India, and everywhere. And also, not only the Region 10 HTC, I conducted a Women in Engineering panel in Global Humanitarian Technology Conference every year in USA. So that we can know the best practices of the smart village women working in Region 7 Canada or other Region 1 to 6 other parts of I should say America, to know their best practices. This is a Women in Engineering conference in the area of electrical and computer engineering. I was the founder of it, and Power and Energy made a huge role. Past president of Power and Energy Society, Prof. Saifur Rahman, attended the program, and many other power and energy experts. And next year we did it from Bangladesh Pune section, Bangladesh Uttar Pradesh section, Bangladesh Thailand section, Bangladesh Bangalore section. And the idea or initiative that we have started in Bangladesh, we have spread it all over Region 10. And I have a dream to one day do it with Kolkata, and your university and NIT can take a lead to spread it. And this is also a leadership summit where we have trained our women international. Only 10 countries in the world get the opportunity, and where we trained our women about nuclear power engineering, because nuclear power engineering is very important, because our government is investing a lot of money for nuclear power plants. And these are some initiatives, like you can also collaborate with Industrial Applications Society, because this is our I should say the sister society. PES, IAS, PELS, Power Electronics, Industrial Electronics, these are all sister societies. And I am the founder of PIACON, a conference between IS chapter and Bangladesh section. And I also want you to know about the social implications of applying machine learning. So that's why it is important to know what is the implications in societal factors while we are applying the technology. So we did symposium like this for disseminate this knowledge, and we must do industry collaboration. And also we did humanitarian activity committee funded women to women empowerment challenge, where actually women were requested to find problem of women faced by Bangladesh women and provide technological solution. Many of the solutions were based on power and energy, and we have also mentored them by connecting them to the entrepreneurs so that they can transform their project idea into product. And these are some awards what Rupa has said. Apart from my many technical papers, best paper award, I have received many regional and global awards for my IEEE activities. These are our Women in Engineering group, which have become the best one in the whole world, and best one in Region 10, of course. And this is as a first female chair, I received 25-year celebration banner from Region 10 director. And I work very hard with my team to conduct many technical events like conferences, workshops like that, and 120 to 130 event, and we own 2018 IEEE Outstanding Large Section Award, and it's a great honor to serve the community and receive awards from IEEE President Jose Mura 2019, now current President Toshi Fukuda in 2020, and Regional Director, past Director, and the future Director. It's a great honor. And also, apart from we do interdisciplinary work, and in 2020, IEEE EMBS Bangladesh chapter has received EMBS Regional Outstanding Chapter Award, and this is the toughest challenge of my professional life. This is TENSIM 2020, where power and energy has a big track, and we have majority of the papers from power energy, but it was in the pandemic. As a general chair, I worked very hard with my team to disseminate information of research outcome of the silent heroes. It's a great honor. This is the first fully virtual Region 10 flagship conference that has hoped to many conference organizers, train many conference organizers to do a virtual one. And I like to disseminate information, as I said before. And immediately after TENSIM, I led virtual conference organizers panel to train our and to share experience, expectation, challenges, and possible solutions in a fully virtual technical conference, which is very important for timely dissemination. Webinar and this faculty development program are part of it, but we have to do our conferences so that we can disseminate information. And I will request you, 12 and 13 September, the first ever Power and Energy Society Women in Power Congress we are organizing, and I in the Asia Pacific region. So I will send email to Navamita, and so that it can be circulated among the participants. I really request you to register the event. Thank you for inviting me. I have shared my technical talk, and also how an emerging area, machine learning, can be used for power grid data. Not only that, I wanted to share the technical contribution we all should make to improve our community, research community, and build the research community. Hope if we can work together, we can do well. Not only that, and we can create impact on people's life. Not only that, and we must have find research collaboration. So for your kind information, if you are IEEE member or not member, no problem. You can reach out to your IEEE members to let them know that I'm running as a Region 10 director. Elect as the top position, and the election is going on. There are other 3 candidates also: Dr. Supagati from Thailand, Dr. Nurliza from Malaysia, and Dr. Lance Fang from Australia. But I really request you to visit my website, www.celiashahnaz.com. I have written in the chat box to know about my contribution, and also visit my Google Scholar citations and see how I can help you. And I really want to help and do collaboration. And if you reach out to me, I will be ready to serve. Thank you for your support. Please spread the message on behalf of me. It will be great honor if you support me, and if you can help me spreading the research and collaboration along with you all. Thank you very much.
Thank you, ma'am.
Monica.
Thank you, ma'am, for this valuable session. I'm blessed to be a part of your session. Thanks again. Ma'am, our HOD ma'am is there.
Yes.
Ma'am, please.
Thank you, madam. And are there any questions from the participants? If there are questions, you can unmute and you can ask. This is the second time madam is with us.
Yes, it is an interesting area. We always think about
Yes.
a very limited area, but actually we inspire all to have interdisciplinary knowledge, that how different algorithms can be employed in your domain. That is important. So that's why I have done from my whole life.
Madam, I am also very much interested in working with you.
Yes, yes. Let us do it.
Yes, so I am also very much interested. Yes, do some collaborative research with you if it is possible. Definitely, I will go ahead.
No, for sure, nothing. We just need a Zoom link. We just need Google with nothing else, and we just need our intention. Now,
Okay, ma'am.
previously, there is an idea that we have to travel, we have to go to Kolkata, we have to make
Yes,
meeting.
yes.
Now the pandemic is so much problematic for us. At the same time, it became so much advantageous for us. Almighty has brought these blessings for us, and now we have overcome all prejudice. Now we just need nothing. We just need one connection to do our meeting and to continue our research. Nothing else. Any questions?
Yes, thank you, madam. What I find is not really. I
Not
don't
really.
think there are any questions. Yes, I would request Madam Rupa
Yes,
Madam
ma'am.
to
Yeah,
present a certificate of appreciation to our
yeah.
Professor Shahnaz. Thank you, Madam, once again for being with us.
Thank you
Yes, ma'am.
very much.
I'm presenting.
Please
Thank
wait
you,
for a moment,
Rupa.
Madam.
Thank you. Thank you very much, and thank you,
Thank
the
you, ma'am.
participants. Okay, hope the session was beneficial for all of you.
Yes, Madam.
Okay, take care and stay blessed. Bye.
Yes, Madam. Madam, please hold for a
Ma'am,
moment
please,
so that the
please.
certificate
Yeah,
is visible to you
I'm sharing
and
Oh,
the
sharing.
participants.
token of appreciation, ma'am.
I understand. I understand. It's great seeing.
Madam, if you could please stop your presentation.
Oh, okay. I understand. Hmm.
Yes.
Yes. Stop sharing.
Yes, ma'am.
Brilliant. Yes, wonderful.
Thank you, Madam.
Thank you, ma'am.
Yes, we
We'll be
become.
sending it by mail. Okay, ma'am.
Yes, yes. No
Okay.
problem.
Thank
No
you.
problem. Thank you
Okay,
for
Madam.
your
Good
call.
day. Good day to all the participants as well. We'll meet again tomorrow sharp at 10 a.m.
Okay.
So
Thank
goodbye
you.
to all.
And goodbye to all. Take care. Have a nice day.
Goodbye for now.
Thank you.
Thank you.
Okay, ma'am.
Take care. Remain connected always, not for this webinar only.
Yeah, yeah.
Bye.
Bye.